Hello everyone. In this tutorial we're going to talk about Panda library. Panda is one of the essential libraries that we use in Python, especially for data science. And we will see how can we create several like structures that can be utilized for the analysis and design of models in machine learning. And we will start by the data frame. Data frame is one of the source data structure in Panda, which has a two-dimension tabular data structure labeled by rows and columns, and it allows us to store and manipulate data in a structured and flexible manner. First of all, before we start doing anything with Panda, we need to import to the library. So we say import pandas, and we import it as BD for simplicity reason. Now, one of the very important structure that we can create using Panda is called data frame. And I would like to create a data frame that can help us to analyze the data that we're going to work with in the next section. So I will create a data frame, create a data frame. I'm going to call it data equal curly brackets. And then I'm going to start with a field called name, and I'm going to define this field as a list of names. Let's call it Alice and Bob. Another name is Charlie, and then last name is David. Okay, so this is the name, four names in the list. This is a list, and then we have comma, and then we start with the next field. I will call it age, and we will have let me just use single quote here. Okay, let's define the age as 25 and 30 and 17. I like to have one under the age, and then 28. Then we add comma, don't forget the comma, and then we define city. Where are they located? Another list of cities. I'm gonna call it New York, and another city is San Francisco, and another city is Los Angeles, and another city I'm gonna call it Alexandria. Alright, and then comma. I'm gonna define the salary for each of those names. Salary is very important because we're gonna do some calculation on the salary later on. I'm gonna define the salary as 100, 150, 200, and 300, for example. All right, so this is for me is the data frame, and then I'm gonna call this as data frame equals to panda dot data frame, and I'm gonna insert data on it. Okay, now if I execute this, so nothing is gonna happen. If I added df like this, df will be printed on the screen. Here we see we have the first column is the name, which has Alice, Bob, Charlie, David. Second column is age, and then city, and then salary. Okay, let me just make this your capital and so on. Okay, of course I can access a variety of columns and variety of rows here. I can, for example, I can say df of, let's say, name. If I would like to access the names, this is the names. I can access the names. I can access actually more than one field. Let's say salary. We have the salary. Can access this uh, salary. Let me see what is the problem with the salary. Yeah, I should have double brackets here to get the salary, because this is not just one salary. That's something we can do. One more thing, we can access a specific row. If I say data frame dot I locate, and then I say uh, for example location 0. You see location 0 give us the age, and uh, the age, which is 25, city New York, salary is 100. So this gives us the row itself. Okay, so as you can see here, we have the Alice. This is the first row. So Alice 25, New York, and 100. This is what we have. Alice New York 25 and 100. If I would like to get the second row, I can do it like this. This will give me the second row, and so on. All right, so that's a very nice features. So I was able to get the column, single column or multiple columns. I can, of course, I can rewrite this to another data frame. That's again possible. So I can select some of these, and later on we're gonna call this features. These attributes we're gonna call it features. So you can create, select as many features as you need for building your model, and then build a new data frame that you can utilize. Okay. Now, what else we can do here? We can also calculate some statistics. I can calculate some statistics on each column. For example, I can say, let's say, for example, if I would like to know the average age or mean age, I can say df of age, and then I can, if I put dot, now I'm gonna get some, functions like, for example, mean, like this. See that? So this is a function mean, and then I can get the mean age, or I can get I can again say df, and then salary. If I would like to get the mean salary of the individuals in the data, I can get the mean salary. If I would like to calculate, for example, the maximum salary, I can calculate the maximum salary. If I would like to calculate the minimum salary, I can calculate the minimum salary, right? So maybe I can do the following: Control C, Control V, Control V, and then I can just add print and calculate here the minimum. Okay, uh, this is the minimum. Let me just do one, for example, for simplicity reason. I can say here the minimum salary is, and then calculate this one. Okay, that's possible. So the minimum salary is 100, and let me take a copy from this. Control C, Control V. Here I can say the maximum salary is, and then convert this to max, and don't forget to close the brackets. And then I can say the mean salary is, and make this mean, and then calculate the output in this case. And once I run this, I get the output. So that this are some statistics I can utilize. If I would like to change this salary to age, for example, I can change this to age, and we can get also the of course this has to be age, this has to be age, this has to be age. Okay, so that this is just a simple simulation on how you can utilize some of the functions that is available on the Panda. Okay, now also you can create a series of one dimension labeled. Okay, for example, using Panda, if I define, let's define something, we call it n data. I don't want to use the same one as data, and then call this 10, 20, 30, 40, and 50, for example, and then say s equals Panda dot series, and then define this as n data. Okay, and then I can, for example, print s. If I would like to print s, that would show me the output. Let's see what's going to happen. Here we go. So this creates a series of values. Of course, I can calculate s also dot min, for example. That should give me 10, or s min, that should give me, I should say s mean or max. Yeah, I think this is a function, so I should have the brackets like this. Yes, that gives me min. So I can also calculate the max, because this is a function. So I can calculate the max, and I can calculate the mean like this. Okay, so that will give me this values. All right. Now this is very nice application for the Panda. Another thing that we can do is Panda. Now we have df, by the way, that we have. Of course we can. So this is df, right? It has everything. Now I can do something else. I can say df dot head. That should give me the. Actually, it's gonna give me df here again. The reason is actually df actually allow you to get the first 5 elements of the data frame, the first 5 elements. So here we only have 4 elements, so that's why we got all of them. All right. If we have more, let's say if I would like just to display 2, I can just say df2. That will give me only 2. Okay. So this is the head. Also, I can say df dot tail. Okay, again this should give me the last 5 elements. As you can see, the last, because I only have 4, so just give me 4. I can say the last one. If I do the last one, this will give me, if I say the last one, this will give me the last element, which is in our case 3. Yes, so this will give me the last. If I say the last 2 elements, this will give me the last 2 elements. All right. What else we can get? Also, we can get something called df.info for the data frame. If you check info, yeah, info, have O is missing here. So if we have info, now this gives you actually the columns, and also if there is any null value in these columns, and also give you the counts and the data type. See, this is object, this is integer 64, because later on maybe we can make a change to this the type of an integer or type of a float or something like that. So data info is helps in getting the we have the number of columns, and if there is any null value, actually it will appear here. Okay. There is another command which is called df.describe. If we look at df.describe, it gives us a very nice thing called the statistics about each elements in the data. So especially, of course, the not the string, but the numbers. So the age gives you the number of counts for the mean, standard deviation, the minimum, the 25, 50, and 75, and the maximum. Okay. If you feel you would like to display this in a transpose way, so that may be interesting somehow. Okay, you can get it in a form of a table like this. This is a transpose. So that looks maybe nicer. Okay. Now, there are also some sort of operation that you can apply on the data frame. You can actually merge two data frame together. I mean, this data frame, this is what we have now. Since we don't have another data frame, maybe I can just merge this data frame to itself. So I can say merged data frame equal, and then say panda dot merge. Okay, and then if I have two data frame, I would say data frame 1, data frame 2. Let me just, for simplicity reason, merge these two same data frame and see what's going to happen based on, for example, name. Okay, and see what's going to happen here. Let me again, I need to print this, because if you didn't print nothing, you cannot see anything on the screen. And here we go. So this is like a repetition of the same data frame based on the name. So the name will not be repeated, but the rest, you see that the age is repeated. So we say age X, age Y, the city is repeated, the salary is repeated. That's the merged data frame. Okay. Now, if I would like to apply a function or an operation on certain column, so if I would like, let's say, apply a function on a column. Let's say you would like to raise a salary, for example, so let's say you would like to define a new column called the new salary, and you would like to raise the salary by a certain amount. So I'm going to say df, and I'm going to define a new salary. Let's say call it new salary, like this, and then it should equal to df of the original salary. Okay, this is the original salary, and dot yeah, I should close this here. Okay, and then dot apply. Now apply is an operation I'm gonna utilize here for including certain operation. Now if I would like to apply an operation, now I'm gonna use something called lambda. So lambda allow us to do an operation, and now for me salary, or whatever the column will be x for me. Now what I want to do with this x, let's say I want x to add, like, let's say $30 extra for the employee. Okay, and then I'm gonna print df. So again, so what I did actually here is I added some amount. So I wrote an equation. So I add the command apply. So apply on the salary column the following. So I say lambda x. So x in this case is a salary, and I'm gonna add to the salary like $30. So this salary should become, like, instead of 100, it should be 130, 180, 230, 330. Let's see what's gonna happen. Here we go. So this is a new salary. So I added a new column here, and this new column here is called the new salary, and I'm getting the extra raise. Of course, you can do any kind of operation. I mean, you can do, for example, instead of raising salary like this, let's say multiply by 1.2, for example, like raising it to 20%. Now we get another payment. Okay, that's the kind of operation that we can do based on. There is also another possibility of sorting the data. So sorting the data based on a column. Let's say I would like to source the data based on the age or based on the salary. So I can say sorted df. I'm calling it with its name. I say df dot sort underscore. See that? You got it, underscore values, and then by which one? By let's say new salary. Okay, and then of course I need to write the sorted df. By the way, you can write print, of course, like this, print df, but I don't really like the way it looks. It looks like this, but if you do not use a print, it should give you this. This is, I think this looks much better. So now I ranked it. So if you look at, so we have Alice, Bob, Charlie, David, Alice, Bob, Charlie, David. Yeah, because the salary here is sort. Let's sort it based on age, because we don't see exactly the way it is sorted here. Let's sort on age. So now I should get Charlie first, yes, and then Alice, and then David, and then Bob. All right. So that's the way we do so. So as you can see here, df salary dot apply. So you apply certain operation, or df dot sort values, and you sort by some value like age. Now another operation that we can do on is to create a new column, for example, based on certain condition. So you can again create a new column based on certain condition. How can we do that? Let's say, for example, I would like to know if the person is adult or minor. So we have somebody here which is named Charlie is underage, so is minor. So if I ask if is it true that the persons here in the list are adult or not, so I'm expecting that Charlie will not be adult, so it should give me a false answer. So if I say df, I would like to create a new column called is adult, okay, and then after that I'll say df, and then I'm gonna work on the age. I have to make sure that it's written correctly, and then I'm gonna apply an operation. Okay, we applied an operation, so I'm gonna say apply an operation here, and again I'm saying lambda, okay, and then x, so as we did before, and then I say the answer is true if x is bigger than or equal to 18, else false. Okay, so I'm asking this question, so I'm adding a new column. This new column should have the original, columns, which is name, age, city, salary, new salary, and another column which is called is adult, and I'm saying the answer is true if x is bigger than 18, else it will be false. If I run this, here we go, I see that I have false with the Charlie, because Charlie does not meet the condition actually, which is 18 years old. All right. So these are most of the type of operation I can do on data frame. Now I would like actually to move to a more advanced um, application, which is now most likely in machine learning we're gonna need to work with a CSV file or Excel file or SQL. Here we're gonna strict our work on CSV, because it's most likely easy to find data for CSV. So what I'm gonna do here, I'm gonna try to load data. If you go to here to the files, if you go to this up arrow, let me load some interesting data called diabetes. This is Indian Bima diabetes, which people have used extensively in the applications. So if you would like to get the correct name, here is the name, Control C, and then close this here. And of course, we already uploaded Panda. So if you didn't upload Panda, you need to upload Panda here. And then I'm gonna say data equal bd dot read, and then underscore CSV file, and then I'm gonna write here diabetes.csv. Of course, there are many ways that you can read this file. You can read this file if you like. You can read it from a website. You can read it from your Google Drive. You can read it from anywhere you like. But for simplicity reason and for the sake of this course, I'm just say upload the file here, and it will be available for you to read. And then after that, if I would like, this is the data. let me call it, yeah, I'm gonna call it data, or let me call it like df1. So for simplicity reason, we already have a df, but now we can call this df. And let's write df1 dot head. Okay, remember we tried head before, but since the number of parameters, the number of rows was limited to 4, so we couldn't get it. But now if I try to do this, here we go. So we got 5 as I mentioned. Okay, so here this data has pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, body mass index, diabetic functions, age, and outcome. All right, so that's it. By the way, if you like to, instead of having only 5, you can say 10, for example. You can read the first 10. I'm just trying to apply the commands that we did before. You can say this tail and get the last 10 elements or 10 rows and so on. See that? So that's a way of doing it, head and tail. We also can do describe if you like. So describe here, give us the count, the mean, the standard deviation, and mean. So we tried all this before. Um, I think we already have it. We've also tried, for example, info. Also that gives us information about the type of data and so on. And by the way, realize it's 768, 768. We don't have any missing value or anything here. Okay, so the data is clean and nice, and it doesn't have a problem. Okay, there are some ways also that we can work with, um, again, different values or different attributes here. Let's just get df. So for example, we can, if I would like to say, again, uh, I have values for pregnancy, for example. Let's say, for example, I would like to know how many pregnancy that happen. I can say df1 and then uh, the pregnancy, and then say, for example, unique. Unique will allow me to know how many times the pregnancy happens. So it is here like 6 times 1, 8, and so on. So that this is the number of, so you can know exactly what are the classes that you have. If I say, for example, for outcome, uh, this should give me just ones and zeros, right? 1 and 0. I say outcome, yes, 1 and 0. That's it. So this is a number of times. Of course, you can also do the mean, the median, the max, the min, as we did before. One of the very important things that we do actually with this type of data set is we need to develop something called correlation matrix. The correlation matrix is actually very useful because it shows how strong is the relationship between different attributes or different features that we have. So if I say correlation, if I would like to define a correlation matrix like this, I can say df1 dot cor, and just like this. And then after that, I can just call this correlation matrix and see what will be the result. Here we go. See, so this gives us, see, in the rows we have pregnancy, glucose, blood pressure, and here we have the same thing. Of course, as you see on the column, the values are 1. Like here it's 1, 1, 1, 1, 1, because the correlation between the parameter itself or that the feature itself. We can, sometimes it's better to call it feature. The feature by itself is 1, but we see here the relationship between glucose and the pregnancy and blood pressure and pregnancy and so on. So we have positive relationship and negative relationship. So when we talk about Matplotlib and Seaborn, we can actually draw this in a much better way. Actually, I would like to do something here that might makes this figure looks better. If I say df1 equal df1 dot rename, okay, and then I would like to rename a column. uh, I would like to rename the column, which is this one actually, diabetes pregnancy function. Yes, this one is a very long one. If I would like to rename it to another name, let's call it what name is good? Let's call it DBF, for example, something like that, and then say DBF1. Let's see how this is gonna work. Yeah, I have a problem here with yeah, I think I need here to use curly brackets like this. Here we go. So that reduce the complexity actually for how it looks like. I mean, I think now it's much better. So it's easy to visualize, right? So the F1, I can say the F1 dot head like this. So you can simplify the names instead of having like a big name like this. That may be gonna be much easier, all right? So for further implementation and further use of the command. Okay, so let's stop here and we're gonna continue the data visualization in the next step. Thank you.